Hello dear students, today we are going to learn parabola, which is part of conic section. So let us first define what a parabola is. So we already know that conic section is a locus of a point which moves in such a way that its distance from a fixed point and a fixed line bears a constant ratio, and that is called eccentricity. So consider a fixed line L and a fixed line, fixed a point S, and suppose a point is moving such that it is maintaining equal distance from this fixed point S and fixed line L, that is PS is equal to PM. So for different position of P, I mean P moving from here to here, these are the positions of moving point P, P1, P2, P3, and it's moving in such a way that its distances from the fixed straight line and that fixed point S is always equal. The curve we will get will be something like this, and this curve is called a parabola. Now let us write the definition of a parabola. So the parabola can be defined as the locus of a point such that its distance from a fixed point and a fixed line are equal, as we have already seen while drawing this diagram. Also, the fixed point is called focus of the parabola, and fixed straight line is called its directrix. So this is the definition of parabola. There are four standard forms of parabola, and first one is y square is equal to 4ax, in which axis is along x-axis, and its directrix is x is equal to minus a, line x is equal to minus a, and you can see here the focus of parabola is a comma 0, and vertex is origin. Now let us discuss some important terms associated with the parabola y square is equal to 4ax. We have already seen that its focus, which is generally denoted by letter S, is a comma 0 for this parabola y square is equal to 4ax. Its vertex is obviously origin, which is 0 comma 0, vertex V. Eccentricity of every parabola is 1, obviously. Directrix is x plus a is equal to 0, or x is equal to minus a. Axis of parabola divides it into two equal parts, or we can say the parabola is symmetric about its axis, and the axis of the parabola is obviously x-axis, which can be written as y is equal to 0. Equation of tangent at vertex. Equation of tangent at vertex. Vertex means 0 comma 0 is its vertex, so tangent at that point is y-axis, and equation of y-axis is x is equal to 0. Focal distance. Focal distance is the distance between any point on the parabola from its focus. So PS is the focal distance. Now if we want to find the focal distance, that is PS, length of PS, which we know by the definition of parabola is equal to PM, where PM is perpendicular distance from any point P to its directrix, and PS is equal to PM. Let us drop perpendicular from P to the axis of parabola and denote its foot as L. So PL is perpendicular on the axis of the parabola from P. Now PM is equal to NL because it's a rectangle, and NL is equal to, which is obviously PM, is equal to this length ON plus OL, and we know by the definition of coordinates, OL is x coordinate, which is h, and ON is a, because it's directrix, so x is equal to minus a is its equation, so length ON will be a. ON plus OL is equal to h plus a, therefore focal distance is equal to h plus a. Now something else, suppose this is a parabola and S is its focus, then any line which intersect the parabola at suppose 2 points A and B and passing through S is called focal chord of the parabola. Obviously chord is a line segment which intersect the curve into 2 points, and if it is passes through the focus of the parabola, then it is called focal chord. Okay, and another thing, if say if I draw a chord which is perpendicular to the axis of the parabola, like this one, AB, PQ, and so on and so forth. These chords which are perpendicular to the axis of parabola are called double ordinates. All these perpendicular chords are called double ordinates of the parabola. And a special kind of double ordinate which passes through focus of the parabola, I mean a double ordinate which passes through the focus of the parabola is called latus rectum. So this perpendicular chord, let us denote it by Q and Q dash. Q dash is latus rectum. Length of latus rectum is 4a. Obviously S, it is passing through a comma 0 and perpendicular to x-axis, therefore we can say that equation of QQ dash is x is equal to a. Now put x is equal to a here in this equation, you will get y square is equal to 4a square, and that will give two values of y coordinate plus 2a and minus 2a. Therefore coordinates of Q are a comma 2a and coordinates of Q dash are a comma minus 2a. So here we can see the length QQ dash is equal to 4a. Next thing we can write it down is equation of latus rectum. Latus rectum means a double ordinate passing through focus. An equation of latus rectum is x is equal to a. Now let us write down the extremities we just found, I mean the coordinates of Q and Q dash. A plus a comma 2a and a comma minus 2a. Parametric equation, x is equal to 80 square and y is equal to 280 is called parametric equation of parabola. Y square is equal to 4ax, and in coordinate form it can be written as 80 square 280. So here t is called parameter. T is called parameter and it's any real number, and obviously 80 square comma 280 will always lie on y square is equal to 4ax. As far as derivation of this equation is concerned, it's very easy to derive this equation y square is equal to 4ax. So we have here p is any moving point h comma k, and by the definition of parabola, pm will be equal to ps, or we can say pm square is equal to ps square, and pm we have already found the value of length of pm, and that is equal to h plus a, which is actually equal to ps also, but pm, take pm as h plus a, so h plus a square is equal to ps square. Now find the value of ps. Find ps with the help of distance formula, which is equal to h minus a square plus k square, and if you simplify this equation, we have k square is equal to 4ah, and obviously point comma k is any point on the parabola, so we can replace it with x comma y, and that will give the equation y square is equal to 4ax, and this is the derivation of the equation of the parabola. Second standard parabola will be y square is equal to minus 4ax. It's similar to y square is equal to 4ax, but opening in left direction, unlike y square is equal to 4ax, which was opening in the right direction. So it's kind of similar to y square is equal to 4ax. Focus is minus a comma 0. Vertex is obviously 0 comma 0. Eccentricity of the parabola is always 1. Directrix is x minus a is equal to 0 or x is equal to a. Axis is y is equal to 0, that means x-axis. Equation of tangent at vertex is y-axis, which is x is equal to 0. Focal distance is a minus h. If you take any point P on the parabola and its coordinates are h comma k, then this length ps you will get as a minus h. Length of lattice rectum is 4a. Equation of lattice rectum is x plus a is equal to 0. Equation of lattice rectum means a double ordinate passing through focus. Extremities of the lattice rectum, that means coordinate of this point q and q dash are minus a. Here difference is minus a. In case of y square is equal to 4x, it was a comma plus minus 2a, but here it's minus a comma plus minus 2a. That means one of the coordinates of q will be minus a comma 2a, and q dash will be minus a comma minus 2a. Parametric equation is x is equal to minus 80 square comma y is equal to 280, and in coordinates form we can write it as a minus 80 square comma 280, where t is a parameter and t is any real number. Third standard form of the parabola is x square is equal to 4ay, which is also called upward parabola because it is opening in upward direction, and its focus is 0 comma a. Directrix is y is equal to minus a. So now let us define the terms associated with x square is equal to 4ay. X square is equal to 4ay. So here a is greater than 0, obviously. In all the cases, all the standard equation, a is greater than 0. Focus is 0 comma a. Vertex is 0 comma 0. Directrix is y is equal to minus a. Axis is y-axis, which is x is equal to 0. Equation of tangent at vertex is y is equal to 0. Focal distance will be k plus a. I mean, if you take any point P on the parabola whose coordinates are h comma k, then the distance the distance ps is equal to pm, and it will be equal to k plus a. Length of lattice rectum is equal to 4a. Lattice rectum means a double ordinate passing through the focus. Extremities of lattice rectum are a plus minus 2a comma a. I mean these 2 points, coordinate of these 2 points, 2a comma a and minus 2a comma a. Parametric equation is 2at comma at square, where t is any real number and t is called the parameter. And the fourth and final standard form of the parabola is x square is equal to minus 4ay, where a is greater than 0. Shape will be a downward parabola opening in downward direction. First one was parabola opening in the right direction. Second one was y square is equal to minus 4ax opening in the left direction. Third one is x square is equal to 4ay, which is opening in upward direction. And final fourth is x square is equal to minus 4ay, which is opening in downward direction. Its focus is 0 comma minus a. Axis is obviously y-axis, and directrix is y is equal to a. And we can find the terms associated with this special parabola. As focus is equal to 0 comma minus a, vertex will be same, directrix will be y is equal to a, acceleration of tangent at the vertex is same, y is equal to 0. Focal distance will be different. Its focal distance will be a minus k for this parabola. Length of lattice rectum will be same 4a. Equation of lattice rectum, see, equation of lattice rectum will change because lattice rectum in this case was above x-axis, here it's below x-axis, so y is equal to minus a will be the equation of lattice rectum for this parabola. Extremities of lattice rectum will also change. It will be plus minus 2a comma minus a, plus minus 2a comma minus a, and parametric equation will also change. It will become 2at comma minus at square. So this was the explanation of 4 standard form of parabola. Y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay, x square is equal to minus 4ay. Now let us discuss some non-standard forms of parabola, and the first one among them is parabola having its vertex at alpha comma beta, where alpha comma beta is not origin, and axis is parallel to x-axis, and length of its lattice rectum is 4a. Then what will be the equation of parabola? So simply in this case what we are doing here is shifting the origin to point alpha comma beta. So its equation will become y minus beta square is equal to 4a x minus alpha. So what we need to do here is replace y with y minus beta and x with x minus alpha, and what we will get is the equation of parabola having vertex at alpha comma beta and lattice rectum, length of lattice rectum is equal to 4a. The figure of this parabola y minus beta square is equal to 4a times x minus alpha will look something like this. Here the axis of this parabola is y is equal to beta. Remember, y is equal to 4ax was our the standard equation of the parabola. In this parabola the equation of its axis was x-axis, that is y is equal to 0. So in this case it will become y minus beta is equal to 0. So axis is y is equal to beta. This is axis. And what about vertex? Vertex is origin is shifted to alpha comma beta, so in that case origin was our vertex, so in new case the vertex will be alpha comma beta. What about focus? Focus will be, coordinates of focus will be, it will be alpha plus a beta, correct? Because initially it was a comma 0. In this case it was focus of y square is equal to 4ax was a comma 0, but now origin is shifted to alpha comma beta, therefore this point a comma 0 will become alpha plus a comma beta. Y coordinate will not change obviously, so focus will be alpha plus a comma beta. Now tangent at vertex will be, tangent at vertex will be a line parallel to y-axis, and obviously it is passing through alpha comma beta, therefore we can say that tangent at vertex is, tangent at vertex is x is equal to alpha. Extremities of lattice rectum. What will be the extremities of lattice rectum? Extremities of lattice rectum will be alpha plus a comma beta plus 2a, alpha plus a comma beta minus 2a, because in this case, original case, y square is equal to 4ax, it was a comma 2a, if you remember, a comma 2a, a comma minus 2a. Now as origin has been shifted to alpha comma beta, therefore we will just add alpha in the x coordinate, alpha in the x coordinate and beta in the y coordinate. So we will get the point alpha plus a, beta plus 2a, alpha plus a, beta minus 2a. Equation of directrix. In the case of y square is equal to 4ax, the equation of directrix was x plus a is equal to 0, if you remember. So in this case what we need to do, just replace x with x minus alpha, so it will become x minus alpha plus a is equal to 0. So equation of directrix in this case is x minus alpha plus a is equal to 0. And finally, parametric equation alpha plus at square. Initially it was at square comma 2at. In this case we will add alpha in the x coordinate and beta in the y coordinate, and thus we will get parametric equation of this parabola. Obviously here t belongs to real number. Similarly, parabola with vertex at alpha comma beta and axis parallel to x-axis and length of lattice rectum 4a but opening in the left direction can be obtained. Its equation will be something like y square is equal to minus 4ax. So y minus beta square is equal to minus 4a x minus alpha will be the equation of the parabola opening in the left direction whose vertex is at alpha comma beta and axis is parallel to x-axis. In this parabola, vertex is obviously alpha comma beta, and focus will be, its focus is alpha minus a comma beta, like what we did in the last example. Equation of axis is y is equal to beta. Equation of tangent at vertex is x is equal to alpha. Extremities of lattice rectum is alpha minus a comma beta plus 2 alpha. Alpha minus a comma beta plus 2a and alpha minus a beta minus 2a. These are the extremities of lattice rectum. Equation of directrix will be is x is equal to alpha plus a. Parametric equation is alpha minus at square comma beta plus 2at, where t belongs to real number. Next type is parabola having its vertex at alpha comma beta, obviously other than origin, and its axis is parallel to y-axis. Length of lattice rectum is obviously in this case also 4a. So let us draw x and y axis and a line parallel to y axis which will serve as axis of the parabola, and let us say this point is alpha comma beta and it is the vertex of the parabola. So it will look something like this. So parabola with vertex alpha comma beta other than 0, 0 and axis is parallel to y-axis and lattice rectum is 4a. So the equation of this parabola will be something like x square is equal to 4ay, and here we need to do, what we need to do in this case is replace x with x minus alpha and y with y minus beta, and we will get the equation. So the equation of parabola of this kind is x minus alpha square is equal to 4a times y minus beta. So this is our equation satisfying above condition. Thirdly, its vertex will be alpha comma beta and the focus will be alpha comma beta plus a. Remember, the focus of x square is equal to 4ay 0 comma a. So focus in this case will be alpha comma beta plus a. Axis will be x is equal to alpha, and equation of tangent at vertex is y is equal to beta. Clearly you can see here extremities of latus rectum. Remember that the extremities of latus rectum of x square is equal to 4ay was 2a comma a and minus 2a comma a. So here it will alpha will be added to x coordinates and beta will be added to y coordinate. So alpha plus 2a comma beta plus a and alpha minus 2a comma beta minus a. Equation of directrix will be y is equal to beta minus a. Remember that the equation of directrix of x square is equal to 4ay was y is equal to minus a. So here we have y minus beta, so y minus beta will be equal to minus a, and this will give y is equal to beta minus a. Equation of directrix. What we need to do in this equation we have to replace x with x minus alpha and y with y minus beta, and remaining things will be same. Parametric equation will be alpha plus 2at as it was in x square is equal to 4ay 2at comma at square, so it will become alpha plus 2at and comma beta plus at square. This is parametric equation. Here you can notice that expression containing x and y is a perfect square. Lx plus my plus n is the expression which is containing x and y, terms both x and y is a perfect square. Now let us learn a new concept, position of a point p x1 comma y1 with respect to parabola y square is equal to 4ax. So you can see here green region is representing exterior part of the parabola, and this pink region is representing interior part of the parabola, and there are infinite number of points lying on the parabola itself. So any point p x1 comma y1 will be inside the parabola. P lies inside the parabola if y1 square minus 4a x1, putting x1 in the place of x and y1 in the place of y. So y1 square minus 4a x1 is less than 0. If p is lying inside this region, interior of the parabola, then this condition will follow. Y1 square minus 4a x1 is less than 0. If p lies outside the parabola, then y1 square minus 4a x1 is greater than 0, and if p lies on the parabola if y1 square minus 4a x1 is equal to 0. So these are the conditions that give you the position of a point, any point p x1 comma y1. With the help of these expressions, finding the expression value of this expression, you can find the position of the point x1 comma y1. Now let us discuss position of a line with respect to parabola y square is equal to 4ax. Consider the equation of the line be y is equal to mx plus c, and obviously parabola we have y square is equal to 4ax. So there can be three position broadly. First one is that parabola does not intersect the line, or line does not intersect the parabola. Second one can be line touches the parabola or intersect at exactly one point, and third situation may be line intersect the parabola at 2 points, that is it becomes a secant of the parabola. So how we can decide that whether y is equal to mx plus c does not intersect, or intersect at 1 point, or intersect at 2 point to the parabola y square is equal to 4x? For that we need to solve the equations, these two equations, and for again we have just substitute the value y is equal to mx plus c in this equation, and then we will have a quadratic equation, and with the help of quadratic equation we can determine whether it is touching or cutting at 2 points or does not intersect. So having these two equations together, we can substitute y square as mx plus c square from equation second one, and this will be equal to 4ax further simplifying it, we will have ms square x square plus c square. So we have a quadratic equation in x, ms square x square plus x times ms square x square plus 2x mc minus 2a plus c square is equal to 0. So we have two values of x if discriminant is greater than 0, one value of x if d is equal to 0, and d is less than 0, then we do not have any real value of x. So let us first find discriminant of this quadratic equation, and it will be 4b square, 4 times mc minus 2a whole square minus 4 times m square c square, and this will further give us m square c square plus 4a square minus 4a mc minus m square c square, or d can be written as 4 times 4a square minus 4a mc, which will further simplified into 16 times a square, 16 times a minus mc. So this is the value of discriminant. We already know that a is positive. In the parabola y square is equal to 4ax, we take a as positive. So 16 times a is positive. A minus mc, if a minus mc, now there are cases. Case 1, if a minus mc is greater than 0, then line is a secant. Or we can say, if c is less than a by m, then line is a secant. Case 2, if a is equal to mc, or we can say c is equal to a by m, then line is a tangent. Line is a tangent. And case 3, if a minus mc less than 0 or c is greater than a by m, then line will not intersect. Line will not intersect the parabola. Intersect the parabola.